Okay, today we're going to be learning about Euler's method, and essentially what you're trying to do is you're given a point, and in this example it's 0, 3, and you're trying to approximate y of 1 in 2 steps, and you're given the differential equation dy dx equals x plus 2. And so the first thing you need to do is you know you're going from 1 to 0, and then you're trying to do it in 2 steps, so that means each step is going to be 0.5, so you need to do y of 0.5, you find that, and then once you find here, you can do find y of 1. So the first thing you need to do is try to approximate y of 0.5. So y of 0.5 equals what you know here, which is y of 0, which is 3, plus the slope at x is 0. So you put in 0 for your x, and for this particular one you get 2, so you plug 2 in for your slope, and then you know your step is 0.5, so you change that here. So what you get is that 3 plus 2 times 1/2 is 1, so 3 plus 1, so y of 0.5 is 4. And so once you have that, you can take your y of 0.5 and do the same thing that you did before, so you plug in. So you're trying to find y of 1 now. You plug in your 4 here, because that's what you just found, and then you're trying to find the slope at this new point, which is y of, you know that x is 0.5 in this equation, so basically this ordered pair here is 0.5, 4, and so you know that your x for this point is 0.5, so you add that here. So you have 2.5 here times 0.5. So then what you get is 4 plus 2.5 times 5, 1.25. So the answer you end up getting is 5.25 as your approximation for what y of 1 will be when you are given the order pair 0, 3 and the slope x plus 2. Okay, so remember that what we have here is just an approximation of what y of 1 would be given this ordered pair and the differential equation. So if we wanted to find the actual, we would integrate this differential equation to get the original, which would be y equals integrate x, which would be x squared over 2, integrate 2, that's plus 2x plus a constant of c. So when we plug in our ordered pair to this, we get 3 equals, which is also our initial condition, equals x of 0 is just 0, 2x is 0, so our c is equal to 3. So we can change this to 3. So now, when our x equals 1, we get y equals 1 squared is 1 over 2 plus 2 times 1 is 2 plus 3. So we end up getting y equals 5.5. So you can see that the error between these two is 0.25. To show again that this is just an approximation for that point. And if you wanted to get a smaller error or a more accurate approximation, you would use more steps in between 0 and 1 to try and get a better approximation for y of 1.
So in the next example that we're going to be solving, the given ordered pair is 4, negative 1, and the given differential equation is x plus y. And so we know, because we were finding y of 4.2, that x will be equal to 4.2 at the end, and we know that initially our x is equal to 4. So our change in x, because we have 2 steps, you can find by doing 4.2 minus 4 over 2. And that will come out equal to 0.1. So for the entire problem, our delta x will be equal to 0.1. So you can just plug that into their equation. So when we're solving for y of 4.1, you plug in our original y value, which is negative 1, and then we have to plug in our original slope value. And you can solve for that by just plugging the ordered pair. So that becomes 4 minus 1, which is equal to 3. So our slope value in this approximation is 3. So when you solve that, it just becomes negative 1 plus 0.3, which is equal to negative 0.7. So essentially we get a new ordered pair, which is 4.1 negative 0.7. So we can now use this new ordered pair to solve for the next approximation, which is for y of 4.2, which is going to be our eventual answer. So these all change except for the change in x. And so you just plug in our old y, which is negative 0.7, and then using the new ordered pair, you solve for the slope again. So to find this, you would just plug in your ordered pair into the differential equation to get 4.1 minus 0.7, which is going to be equal to 3.4. So you just plug this slope into your equation to get 3.4. So it all comes out to negative 0.7 plus 0.34, which will be equal to negative 0.36.